Deep ebony skin. Deep ebony skin represents the highest concentration of melanin that human evolution has ever maintained on a large scale. Melanin, the pigment responsible for skin color, also functions as the body's primary defense system against ultraviolet radiation, essentially nature's original sunshield, long before modern solutions existed. This level of pigmentation evolved in equatorial regions, particularly across Central and Eastern Africa, where ultraviolet radiation remains intense throughout the year. In these environments, sunlight is not seasonal, subtle, or forgiving. Exposure is constant, direct, and biologically demanding. Under these conditions, high melanin production was not optional or decorative. It was a requirement for survival. Melanin works by absorbing and dispersing ultraviolet radiation before it can penetrate deep into the skin and damage DNA within cells. Without this protection, mutation rates increase, cellular repair systems become overwhelmed, and the risk of sun-induced cancers rises sharply. Deep ebony skin minimizes these risks by acting as a biological filter, reducing the amount of radiation that reaches vulnerable tissues. This pigmentation often produces cool or bluish undertones, a visual effect created by densely packed melanin granules beneath the skin's surface. These undertones are not accidental. They reflect the physical structure of pigment distribution optimized for maximum protection. Populations in East Africa, particularly Nilotic groups, exhibit this phenotype most prominently. These groups also historically lived at higher altitudes, where ultraviolet radiation is even more intense due to thinner atmospheric filtering. Combined with open landscapes and limited natural shade, the environment applied consistent evolutionary pressure in one clear direction: more protection, not less. Beyond sun defense, deep ebony skin also demonstrates remarkable resistance to premature aging caused by ultraviolet exposure. Collagen breakdown, DNA fragmentation, and cellular stress occur at lower rates under comparable sun conditions. In other words, when the sun is doing what it always does, this skin is already prepared. Visually striking, yes, but its real significance lies in efficiency. Deep ebony skin represents the upper limit of pigmentation required to maintain skin integrity, genetic stability, and long-term survival in environments where the sun never takes a break and evolution does not reward compromise. Rich, dark brown skin. Rich, dark brown skin contains slightly less melanin than deep ebony tones, but still enough to make ultraviolet radiation a manageable problem rather than an existential one. It appears as a deep brown shade, often accompanied by warm golden or reddish undertones, reflecting subtle differences in pigment type and distribution. This tone evolved across West Africa and parts of South Asia, regions where sunlight remains strong but does not behave identically year-round. Seasonal shifts, humidity changes, vegetation cover, and cloud patterns introduce variability, and evolution tends to respond to variability with balance rather than extremes. The melanin density in rich dark brown skin still provides strong protection against DNA damage, significantly lowering mutation rates and reducing the likelihood of sun-related skin conditions. Cellular repair systems operate under less stress, and long-term ultraviolet exposure becomes survivable rather than damaging. At the same time, slightly reduced pigmentation compared to deep ebony tones allows more ultraviolet light to penetrate the skin. This matters because vitamin D production requires UV exposure. Blocking too much radiation creates a different problem entirely: nutrient deficiency, weakened bones, and compromised immune function. Rich dark brown skin occupies a functional middle ground. It blocks enough radiation to prevent damage while allowing sufficient penetration to support vitamin D synthesis. Evolution tends to favor these compromises in regions where environmental conditions are demanding but not absolute. This balance made populations with rich dark brown skin particularly adaptable. They could thrive across wide equatorial and subtropical zones, tolerate migration, and adjust to changes in landscape without requiring radical physiological shifts. In evolutionary terms, this skin tone reflects a successful negotiation. Not maximum defense, not maximum absorption, just enough of both to keep survival consistent across generations without unnecessary risk. Mahogany brown skin. Mahogany brown skin is characterized by a deep brown base with noticeable reddish or copper undertones. This tone developed in tropical and subtropical regions, where sunlight remains intense but is no longer constant or extreme throughout the entire year. The melanin level provides reliable protection against ultraviolet radiation, preventing rapid burning and limiting cumulative DNA damage. At the same time, it allows greater ultraviolet penetration than darker tones, improving efficiency in vitamin D synthesis during periods of lower solar intensity. This fine adjustment supported populations living in regions shaped by migration, trade routes, and environmental diversity. Parts of Melanesia, South Asia, and coastal or forested areas experienced fluctuating exposure due to terrain, vegetation density, and seasonal weather patterns. Individuals with mahogany brown skin often tan easily and evenly. This is not cosmetic behavior, it is an adaptive response. Tanning increases melanin production temporarily, allowing the skin to adjust its protective capacity in real time rather than relying on a fixed setting. Evolutionarily, mahogany brown skin reflects flexibility. It offers stronger baseline protection than lighter tones while remaining responsive to changing environmental demands. In unpredictable climates, this responsiveness becomes a survival advantage. This pigmentation represents a skin type optimized not for a single environment, but for movement, transition, and adaptation, qualities increasingly important as human populations spread across continents. Light golden brown skin. Light golden brown skin appears as a lighter shade of brown with warm, sun-kissed undertones. It developed in regions such as the Mediterranean, North Africa, and parts of South Asia, areas where sunlight is abundant but moderated by seasons, latitude, and weather variability. Melanin levels in this tone provide enough protection to reduce burning and DNA damage during periods of high exposure, while still allowing efficient vitamin D production when sunlight weakens. This balance reflects adaptation to climates that are neither extreme nor stable. A defining feature of light golden brown skin is its ability to tan quickly and evenly. This tanning response acts as a temporary upgrade, increasing protection during intense sunlight without permanently blocking ultraviolet absorption year-round. Over generations, this adaptability allowed populations to endure hot summers without excessive damage while remaining nutritionally stable during cooler, darker months. The skin responds dynamically instead of locking into a single survival strategy. From an evolutionary perspective, light golden brown skin represents fine-tuning. Small adjustments in pigmentation distribution produce significant improvements in resilience, demonstrating how evolution optimizes efficiency rather than perfection. Olive tone, skin. Olive tone skin is distinctive for its neutral base combined with greenish, yellow, or gray undertones. It is also known for appearing different under different lighting conditions, which tends to confuse observers far more than it confuses biology. This tone evolved in southern Europe, the Middle East, North Africa, and parts of the Andes, regions characterized by fluctuating climates, changing seasons, and inconsistent solar intensity. Melanin levels are moderate, providing protection during strong sunlight while allowing sufficient ultraviolet penetration when light levels drop. This balance supports both skin integrity and vitamin D synthesis without requiring extreme specialization. One functional advantage of olive skin lies in its optical neutrality. By appearing darker in bright light and lighter in shade, it naturally moderates exposure. While this effect is subtle, evolution tends to exploit subtle advantages repeatedly over long time scales. Populations carrying this trait often lived along major migration corridors, where genetic mixing was constant. As a result, olive skin reflects both adaptation and diversity, shaped by environmental pressure rather than isolation. Evolutionarily, olive skin is a study in flexibility. It resists damage when necessary, absorbs light when possible, and adapts without drawing attention to itself. Warm beige skin. Warm beige skin sits between light brown and fair complexions, with a neutral base that may lean golden, pink, or gray depending on genetic background. It is common in southern and eastern Europe, parts of Latin America, and regions of West Asia. Melanin levels here are lower, providing less inherent sun protection but greater efficiency in ultraviolet absorption. This balance evolved in regions with pronounced seasonal cycles, where populations faced long periods of weak sunlight followed by brief intervals of stronger exposure. Warm beige skin tans relatively easily, increasing melanin production during sunnier months and adding temporary protection. During darker seasons, reduced pigmentation allows greater ultraviolet penetration to support vitamin D synthesis. This adaptability reduced the risk of deficiency-related conditions such as weakened bones or compromised immune function, particularly in populations living farther from the equator. Rather than maximizing protection or absorption, warm beige skin manages both moderately well. Evolution rarely demands extremes when adaptability can solve the problem instead. Fair light skin. Fair light skin contains relatively low levels of melanin, producing a pale beige or pinkish appearance. This tone developed primarily in Central and Northern Europe, where sunlight is limited for much of the year. With less melanin-blocking ultraviolet radiation, fair light skin absorbs UV efficiently, significantly boosting vitamin D production. In regions with long winters and low sun angles, this efficiency was critical for maintaining skeletal strength and immune health. The trade-off is reduced protection under intense sunlight. Fair light skin burns more easily, accumulates damage faster, and requires behavioral adaptation when exposed to strong UV. However, in environments where strong sun is rare, this vulnerability carried minimal evolutionary cost. Here, survival favored nutrient efficiency over protection. Without sufficient vitamin D, long-term survival becomes unlikely regardless of sun damage risk. Fair light skin demonstrates how evolution prioritizes what matters most in a given environment, even when that choice comes with obvious downsides elsewhere. Very fair skin. Very fair skin represents the lowest concentration of melanin in the human spectrum. It often appears milky white or translucent, with visible veins beneath the surface due to minimal pigment coverage. This phenotype developed in Northern Europe, particularly in Ireland, Scandinavia, and the Baltic regions, where sunlight is scarce for most of the year and often filtered through cloud cover. In such environments, producing high levels of melanin would have blocked the limited ultraviolet radiation available. By reducing pigmentation, very fair skin maximized UV absorption, ensuring sufficient vitamin D synthesis even under weak, indirect light. Although extremely vulnerable to burning under intense sunlight, this vulnerability posed little risk in regions where intense sun was rarely encountered. Evolution responds to what exists, not what might happen elsewhere. Very fair skin represents extreme efficiency under extreme limitation. When light is scarce, wasting it is not an option. If you learned something new, drop a like, share this with someone curious, and hit subscribe for more explained videos.